pressure looks good.
Doubling up. Roger roll, Atlantic.
Water towers can fly! Yes!
Tango Delta nominal.
Flight down, feed off. Bring in, feed off. Off.
Yikes. You bet. Okay. We don't need any more of these.
Hello everyone, welcome back to our live coverage of Launch Vehicle 6, or LV0006, Astra's third orbital launch attempt. You're looking live at the rocket on the launch pad at Kodiak Island, Alaska, and we're coming to you live again from Alameda, California, Astra's headquarters. My name is Thomas Burkhart, News Director for NASASpaceflight, and I'm joined once again by Carolina Grossman, Director of Product Management at Astra. Carolina, thanks for joining us again today.
Thanks for having me, Thomas.
So as usual, over the course of today's broadcast, we'll be taking your questions live. So if you have questions about what we're talking about, what you're seeing, please throw them in the chat. Tag us with @NASASpaceflight. We're going to get through as many of those as we can over the course of the countdown and the launch. But before we get into questions, Carolina, can you give us an update on how we're looking for today's launch attempt?
Yes, of course. We are at T-minus 57 minutes and about 40 seconds from our liftoff time. The team has recently completed the go, no-go to complete propellant load, and as you can see, that frost line beginning to appear on the first stage, and the weather is looking beautiful in Kodiak, so fingers crossed for a smooth ride to orbit today.
Thanks, Carolina. We know we were a little delayed getting into today's webcast and into today's launch attempt. Can you tell us a little bit about why we had a hold earlier today?
Yes, so due to the abort that we had yesterday around our T0 time, we made some operational adjustments, including a planned hold that just concluded about 15 minutes ago in order to precondition the vehicle for flight, and we believe that this should address the issue that caused the abort yesterday.
If you were watching live with us yesterday, you know LV0006 got all the way down to engine ignition. You're seeing a replay on your screen now from yesterday. All 5 engines did light, but shut down before liftoff. The data showed that those 5 first stage engines were ramping up to full power slower than normal, so as designed, the vehicle detected this and the launch was automatically aborted. After carefully reviewing the data, the Astra team has made some operational adjustments, and those should resolve the issue for today's launch attempt. Right now you're looking at the rocket on the pad, and as Carolina pointed out, you're seeing that frost line up top. As we talked a little bit about yesterday, that is the liquid oxygen tank on the first stage, getting nice and frosty from the cool liquid oxygen on the inside, condensing the air around the rocket. Below that is the kerosene tank, which is not super cold, so there's no frost line on the bottom part of the rocket's first stage. Astra, for those who may not have joined us yesterday or need a reminder, can you tell us just a little bit about what today's mission is all about?
Yes, the mission today is for the United States Space Force as part of the Space Test Program. We do have a test payload aboard our vehicle, and this means that it is Astra's first commercial launch. It is a test payload, so it will not be deployed, but we will send a signal that would simulate the deployment and test that capability.
Gotcha, and this is of course Astra's third orbital launch attempt. 2 prior launches. Want to talk a little bit about how those launches led into today?
Yes, so every launch that we have conducted of our Astra vehicles, we intend to learn from and improve. Our last launch in December, we made it very, very close to reaching orbit. We were just half a kilometer second short of reaching that orbital velocity, but it was a fantastic outcome from what we were hoping to achieve. And so with this vehicle, we've made adjustments, we've resolved that issue, and we've made a few other enhancements in order to improve our payload capacity on this flight. And with that, we're hoping for a great outcome with today's launch.
Can you talk a little bit about what those upgrades and changes were between Rocket 3.2 and the debut of Rocket 3.3 today?
Yes, so first of all, the issue that caused us to fall a little bit short of orbit was an issue with our mixture ratio control on the vehicle, and so we addressed that issue. And so we expect to deplete our propellants in the appropriate way so that we can make it to orbit today. We also stretched the first stage tank 5 feet to allow for additional propellant to provide more payload capability, and we consolidated several components on the upper stage of the vehicle to, again, provide more payload capability.
Gotcha. Thank you very much, Carolina. We'll keep the questions coming. If you have questions in chat, tag us at NASASpaceflight. We're going to start getting into those here. First question, talking about where are we launching from today? It's a beautiful launch site up there in Alaska. Can you tell us a little bit about Kodiak?
Yes, so you can see our launch site is in beautiful Kodiak, Alaska. That is 250 miles south of Anchorage and is actually the second biggest island in the United States after the big island of Hawaii. And it is the home of the Pacific Spaceport Complex America, which is was opened in 1998 and has been the site of previous Astra launches. We really enjoy both the beautiful scenery there as well as working with the fantastic PSCA team, and we are very grateful to them for their support in continuing to operate safely and efficiently.
And I believe there are some advantages from taking these early test flights up there in Kodiak. It's not a very busy launch range. It's not one of the traditional Cape Canaverals or anything like that. And it's also very remote. I believe that gives you some advantages on these early test flights.
Yes, absolutely. It's been great to be able to work with the team and get the opportunity to have such long launch windows. For example, our launch window for this mission extends through September 11th, which would be very difficult to achieve at a busier range. And so that's just one of the many reasons that we enjoy launching out of Kodiak.
So in addition to Kodiak, what is Astra looking for in potential future launch sites outside of Alaska?
Well, we're looking to get our customers where they need to go. So we are exploring launch sites within the U.S. We are on a mission to provide daily space delivery, and the location of our launch sites will really be determined by where our customers need to go. So from different spaceports, you have access to different locations in space, and so this launch site in Kodiak is particularly advantageous for polar orbits and high inclination orbits, but if our customers need to go to lower inclination orbits, then that would be more challenging to get to from a place like Kodiak.
Gotcha. Before we dive into some more questions, let's listen in to the pad mics and the teams on the countdown net as the countdown proceeds past T-minus 51 minutes and counting. And joining our live coverage now is Benjamin Lyon, Chief Engineer at Astra. Benjamin, thank you so much for taking some time to join us today.
My pleasure, Thomas.
So can you talk a little bit about what your responsibilities are here at Astra?
Sure. Well, really, I think it makes sense to talk about Astra's story so far. I think really Chris and Adam have done an amazing job to get Astra to a place where it has demonstrated orbital capability. And so my background is really about taking key technologies and taking them from prototypes to products. And so that's really my job at Astra, is to help Astra really get to that next step.
And how are you leveraging your prior experience to make that happen here at Astra as we're looking at one of the hopefully final test flights before moving into a more operational phase?
Sure, it's a good question. I think there are a couple of things. The first is, I think there's an incredible value to focus. This is one of the things I've learned in my career. And so really focusing down on executing our ability to get from to the rate we want to hit this year, as well as build this team that is already a set of incredible people out to a size of a team that can really execute.
Yeah, heard you talk a lot about, and when we're here at Astro, we see a lot of the teams that are building these kind of rockets and all of these systems. They come from a lot of different backgrounds, and there's some really unique perspectives coming in to make a truly different launch service. Can you tell a little bit about just how valuable that team really is?
Yes, you know, when you want to create a complete product, it's really a whole set of things that come together. It's not just the hardware, it's not just the software, it's not just the services, it's not just the factory operation. It's all these things have to come together. And when you bring folks from a broad variety of experience, people from tech, people who are rocket scientists, people who have experience working with the various different kinds of customers that Astra has, that makes a real magic happen. And so building a team of folks that are really great also attracts other folks who are really great. So all of that put together makes just a really kind of magical elixir.
That's so cool, and it's definitely visible here at Astro. You see it all everywhere. What is your and your team's biggest engineering focus at Astro right now?
Well, we're really focused on execution. You know, you saw Vehicle 6 is on the pad right now. We've got Vehicle 7 in flight, well, in production. And that is where we're completely focused, is making sure that we maintain the learning velocity and we learn everything we can from every time we go to the pad. And we apply that learning and iterate as quickly as we can.
Gotcha. And lastly, one last question before we let you go. Once we get a little further into this countdown and we're getting towards T0, where are you going to be watching from and what are you going to be doing at liftoff?
Well, I will be helping out the team as much as I can on comms outside of mission control. Usually I find myself in mission control for the last 15 or so minutes. But my job at the end of the day is to let these folks do the great work that they do.
Awesome. Benjamin, thank you so much for taking some time to join us, and good luck to you and the rest of the team on today's launch.
Thank you, Thomas. Appreciate it.
Let's go back to the pad and listen in for some activity on that countdown net as the countdown proceeds past 46 minutes and counting. And welcome back, Carolina. We're going to get into some live chat questions here. Our first question, we were talking about Kodiak Island, the launch site, a little bit earlier, and we have a question in chat asking us how the rocket got up to Kodiak.
Yes, so one of the most unique aspects of Astra's launch system is that everything that you see on the screen that is not physically attached to the ground is shippable in standard shipping containers. The rocket itself fits inside a 45-foot shipping container, so we actually send everything up directly from our headquarters and assemble it on site. We also use this exact same test setup at our facility in Alameda, as well as where we conduct our static fire test, which is approximately 2 hours away from our headquarters, which allows us to test exactly like we are going to fly.
That's very cool, and that's a big part of Astra's not only flexibility in launch sites launching from anywhere like with a concrete pad and an internet connection, but also eventually ramping up to a much higher launch cadence.
That's right. We see the opportunity for us to be able to set up a spaceport really wherever we need to meet our customer requirements and what they need and when they need it.
So another question in chat just asking how tall and wide is this rocket, and even if it can fit inside a shipping container, can't be too big, but it is a dedicated small launch vehicle. Can you tell us just a little bit about how big it is?
Yes, absolutely. We have a 43-foot overall length of the vehicle, and the diameter is 52 inches. For some other facts, the first stage has 5 Delphin engines, which are developed and produced, manufactured, and tested here at Astra, and the upper stage is powered by a single ether engine, which is also an engine that we have developed, built, and tested entirely in-house.
And in fact, I believe that test facility is just in a building across from the one we're standing in right now. Those test cells were really cool to see during our factory tour last week.
That's right. It's really something to see an engine get built up in the morning and carted over to our test stand across the street and set up and often fired that very same day. It really helps us innovate and learn and gather test data and make improvements very quickly. So we are very thankful to have these amazing test facilities here at the former U.S. Naval Air Station in Alameda.
Another question from chat, are there advantages to having such a small launch vehicle when it comes to development and consumer construction of the rocket?
Yes, there are many, many advantages, I think, of having a small launch vehicle. First of all, a lot of what we're seeing in the satellite industry is that payloads are getting smaller, and while it's kind of like the airline industry, if you have a lot of passengers that all want to go to the same place, well, you know, those big jumbo jets, those large rockets really make sense to get there. But if you need to get there faster and you can't wait for that commercial flight, or if you need to get to a destination that's not quite as popular, then a vehicle like Astra's makes more sense. And we believe that the dedicated small satellite market is something that we're really interested in. And in terms of development, obviously it takes time to build and develop all of the parts that you see on the rocket and in our launch system. So the smaller rocket is faster to build, frankly.
Gotcha. Continuing on with questions in chat. Again, if you have more questions, tag us with @NASASpaceflight. Throw those in the chat. We're going to keep going through those throughout today's countdown. And our next question is talking about where this launch is going. We know it's going to low Earth orbit, but can you tell us more specifically about what type of orbit the rocket is aiming to achieve today?
Yes, our target orbit today is an altitude of 415 kilometers and a 70-degree inclination. And again, we are sending a test payload for the U.S. Space Force as part of the Space Test Program. It will not be deployed as part of today's launch, but we do have a payload on board this flight.
So a very nice high inclination orbit, which is an advantage of launching out of Kodiak near the poles. I know we were talking about that in depth the last time as well, but not quite a polar launch per se. I'll keep going with the questions here. Here is a great one, and I know we have a camera view to show this, because some people in chat are asking about the guy with the mohawk. He's very popular in chat right now. Can you tell us a little bit about Mr. Launch Coordinator Chris Hoffman?
Yes, absolutely. So we can talk a little bit about these folks in our mission control. The gentleman with the mohawk you see there, that is Chris Hoffman, who is our launch conductor. He is responsible for overseeing the operations and following all of our procedures, and has the authority to call hold, recycle, or abort as required. And as a fun fact about Mr. Hoffman, on the side, when he's not launching rockets, he does run a cat rescue. It's rocketcatrescue.org and on Twitter, and so we love to support our space cats. And I can also talk a little bit about the other folks you see in mission control. To Chris Hoffman's right, which is our left in the navy blue long sleeve shirt, that's our launch director, Chris Thompson. He is the final launch authority and is responsible for the safety of overall launch operations. Then continuing counterclockwise at the top is our FAA officer, Luigi. And then we have our flight safety system coordinator, who is Lucas, and he is responsible for the onboard flight safety system. Next to him is Dan Wilson in the green shirt, who is our guidance, navigation, and control master, who ensures weather and wind trajectory information is up to date, properly loaded, and meets flight criteria. Then to continue, we have our Tango, who is Steve Lai. He is the vehicle controller, and so he's the one who is actually operating the vehicle. You will often hear him when we're listening into the countdown net. And then at the bottom of your screen, you see Chris May, who is our CDH, or Command and Data Handling. So he's monitoring and adjusting all of the software and is following commands from Chris Hoffman, our launch director, or our launch conductor. And then finally, in the googly eyes, that is our flight activities officer, Joshua Green. And he is responsible for keeping track of all of our activities during today's launch. So this crew of 8 folks is located here in our headquarters in Alameda, actually right behind our camera crew. Up in Alaska, we have a team of 6, our red team, that is on the ground helping to set everything up, and a huge shout out to them for all of the work they do. Having a small team to be able to operate the vehicle and set up our launch site has been a huge part of why we've been able to continue operating safely and efficiently during our ongoing COVID-19 pandemic. So we thank the red team for staying safe and for all that they do.
Absolutely, and we know we just went into a lot of detail with a lot of different people, but in reality, that's actually a very small team, relatively speaking, for launching a rocket, which is, of course, part of Astra's operations. So, but very cool. For the introduction of our mission controllers today, we'll be listening in to them on the countdown net throughout the countdown. In the meantime, let's get back to some questions here. And we have one asking, is Astra hoping economies of scale will make up for the lack of reusability in this rocket?
Yes, definitely. That's one of the important things that we like to abide by at Astra, is that simple scales. So we are counting on making a mass-produced, low-cost rocket in our journey to achieve daily space delivery and to improve life on Earth from space. So we are hoping that the economies of scale and using typically more low-cost materials will help be able to deliver on that promise.
And then the second part of this question, talking about Astra's competitors in the small sat launch market, we know there are several new small sat launchers in various stages of development. What sets Astra apart from those other companies?
I think there's a lot of things that set Astra apart, but certainly I think our approach to using more low-cost materials, a lot of what you see on the rocket actually comes into our factory as raw sheet metal, and our in-house machine shop turns those parts into flight hardware. We tend to stay away from 3D printed materials and other costly materials in order to make the rocket as cost effective as possible, so we can help our customers get to space not only more efficiently, but also in a more cost effective way.
And we're looking live at our screen. We're seeing some vapors coming off of that black structure on the right. Can you tell us a little bit about, first of all, what is that black tower next to the rocket?
Yeah, so that is our strong back that supports the rocket, and you can see a lot of umbilical wires that connect the rocket and the strong back, so that's how we pump the propellant onto the vehicle. There's also communications links to the vehicle that are provided by the strong back, and then we do vent the system to maintain our pressures right where we want them.
And if I'm not mistaken, so that vent we're seeing from the strong back right now is probably liquid or gaseous oxygen, obviously. Am I correct in that?
I believe you are correct.
And of course, along the side of the rocket itself, we're seeing some condensed air, water vapor forming around the rocket as the super cooled liquid oxygen tank begins to fill and cools the air around it. We see that on a lot of different rockets around the industry, and Rocket 3 is no different. We're coming up on 33 minutes and counting, and we're going to keep going in with these questions. If you have questions, put them in chat. Tag us at NASASpaceflight. You all know the drill. Let's take a quick break and listen in for activity on the countdown net and those pad mics as the countdown proceeds.
This is Astra LC on countdown. We are holding at T-minus 30 minutes for propellant fill.
And as you just heard, a hold has been called at T-minus 30 minutes and counting. We will stand by for more information and provide it when we have it. Again, there's a fair bit of time in today's launch windows, so we'll stand by and hope for an attempt later this window.
Yep, that's right. We just got the word that the hold was due to propellant load. So as you can see, we are filling up our tanks, and we are holding to catch up to the point we are in our countdown.
All good so far.
Also looking good.
So while we are waiting for this hold to continue, while they're waiting for propellant load to catch up on the vehicle, we're going to take a look at an interview from last week where I sat down with Astra's founder and CEO Chris Kemp to learn a little bit more about Astra's mission and today's launch. So let's take a look at that. Hi everybody, I'm Thomas Burkhardt with NASASpaceflight here at Astra's headquarters, and I'm here talking to CEO Chris Kemp. Chris, thank you so much for joining us today.
Yeah, thanks for having us.
Thank you for coming on to NASASpaceflight Live. That was an absolute pleasure. Some stuff has happened since, and we're getting ready for the launch of Rocket 3.3. What are your expectations for this upcoming launch?
Well, we hope to learn a lot. This will be a test flight of our improved Rocket 3. We'll be taking a test payload from the Space Force, and hopefully we'll have a full flight, so we'll be able to collect a full set of data for them.
And how confident are you in the success of Rocket 3.3?
Well, I think we'll learn a lot, and I certainly hope we get a full flight in. A lot of changes have been made, and we've incorporated all of the data from a complete flight back in December into this new version. And regardless of what the outcome of the flight is, we'll take whatever we learn, we'll make whatever changes, and we'll fly again.
What shift in the industry at large is the most important to you, and what is Astra's role in that?
Well, I think the ability to quickly iterate. We're seeing both Astra and other companies quickly make another version, learn as much as they can, and then iterate. And it's really particularly easy to do with such a small launch vehicle.
So you mentioned launch sites. What kind of places are acceptable for Astra's rockets to launch? Are you limited to the places we traditionally think of, normal launch ranges, or is there infrastructure or regulatory infrastructure in place to launch from pretty much anywhere?
Well, we can basically launch anywhere we have a license, which means we just need to find a place where we're far enough away from population centers to not bother people. And we're investigating over a dozen different locations, both domestically and abroad. Our system could be completely shipped and unpacked, and we can launch a rocket within a few days. So you can kind of see how that enables us to be very flexible. And we're going to continue to be able to develop and iterate on the entire launch system, including the spaceport, at that same rate.
So just on Thursday, I believe Astra received their authorization to operate out of Kodiak, Alaska through 2026. Can you talk a little bit about that?
That's right. We received a launch operator's license from the FAA, and that allows us to launch this version of the vehicle through 2026. It means we don't have to go through a licensing process for every single launch, but as long as we're launching out of the trajectories with the current spaceport, current rocket.
What kind of forward work is needed to start launching these rockets from more non-traditional locations, things that are not already established spaceports?
Really, from our perspective, it's just a licensing issue. So we just need a fence and a concrete pad, and we bring our infrastructure in and we launch. So very little actual work needs to go into setting up the site. A lot of work needs to go into make sure that we're not going to interfere with the community and we're not going to cause any disruption. So we try to find places that are away from cities and population centers, typically in coastal areas.
So on NASA Spaceflight Live, you mentioned a point-to-point cargo delivery system as part of the future of Astra. But I believe Astra is looking externally for the re-entry part of that. Can you talk a little bit about that decision?
Well, I think that Astra's focus right now is in mass producing and scaling launch operations. That focus means that we're not off building larger rockets. We're not going to try to put people on our rockets. We're not going to try to work on reentry systems. And so it's a natural area where we can get something to space. We're going to partner to try to figure out how we get it back to the Earth safely.
You know, some other companies have made that same promise of saying, listen, we're in the small sat launch business. We're never going to go to bigger rockets. Some other companies have ended up changing their mind. How set are you on that? Is that something you're completely off the table or open to potentially, if the market calls for it, Astra serving into that market as well?
Well, we've already sold over 50 launches, and we're very focused on what our customers ask us for. And right now, there is an overwhelming demand for point-to-point launch services. And what that means for us is we can't scale fast enough, and we can't focus more attention on continuing to drive the cost down and the scale up of the launch services that we provide today.
What do you believe is the sweet spot capability for a small sat launch vehicle as far as size is concerned?
Well, for Astra, it was the smallest rocket that would meet the needs of today's market today. And that's the 50 kilogram class Rocket 3 series. As we start to see more large mega constellations come online, that sweet spot moves to around 150 to 200 kilograms, where we ultimately seeing it settle out from an economic perspective is a small rocket that can deliver approximately 500 kilograms to a mid-inclination orbit.
Do you think that you'll fly a lot of missions that are basically a three-stage vehicle similar to Rocket Lab's Electron once you have that spacecraft bus coming online?
Yeah, we think that having more ability to add capacity to the upper stage gives us a lot more flexibility. So the Apollo Fusion engine is a great example of a technology that lets us have more precision and more capacity.
And so these design changes or designs that you're looking towards and the evolutions that you're aiming towards, how does that market and how does that compare to your competitors that are also in the small sat market, which is growing seemingly by the day?
Right, well, what we're trying to do is focus on flight rate above all else. So if we can fly, for example, next week, we'll take what we learn. So that next rocket will benefit from whatever we learn.
On launch day for this upcoming rocket, how is that going to look different from the previous launch as far as personnel involved, the countdown process as far as automation is concerned?
We're really very similar to the previous launch. We have about a half a dozen people up in Alaska. We have about a half a dozen people in a launch control room here. And we're going to be running the launch using a lot of the same software and systems that we used in December.
So what is the objective of this upcoming launch with regards to Astra serving the Space Force in the future?
Well, this will be the first launch of an orbital launch system. So it'll be a test launch being performed for the Space Test Program within the Space Force. What we'll be doing is we'll be launching to a very specific orbit and inclination. We'll be watching that closely. We have a test payload that's been instrumented. So we're going to be looking at the vibrational environments, the acoustic environments, the thermal environments, so that we can give all that data to the Space Force. So this payload will not be deployed from the spacecraft, but we're going to measure our ability to get it exactly where it needs to go.
And it was great to sit down with Chris Kemp earlier last week prior to today's launch attempt and the launch attempt yesterday. Just a pleasure to sit down and talk with him. If you are just joining us, today's launch attempt is currently in a hold. You can see we're at T-minus 30 minutes and holding as teams are just working to catch up on their propellant loading operations before continuing into the really business end of the countdown. In the meantime, Caroline, if it's okay with you, let's dive into some more questions.
Keep them coming.
All right. So a question in chat asking about what do you use to light those Delphin engines on the first stage? Talk a little bit about that.
Sure. So again, our first stage is powered by 5 Delphin engines that are developed and built and tested here in Alameda. Each engine produces 6,500 pounds of thrust at sea level and is powered by liquid oxygen and kerosene. And we actually have a ground-based ignition system, which is one of the unique features of our vehicle. So in order to make the rocket as simple as possible, we try and put more of the more parts into the ground that doesn't fly so they can be heavy. And so we keep the engines as simple as we can. So we use a ground-based ignition system.
So if I understand that correctly, it's about taking as much mass as possible for all the systems needed to begin a rocket launch and putting them as many of them on the ground as possible so that once you lift off, you're not carrying all of that mass with you.
That's right. We can better use that mass to increase our payload capability.
And on the other side, you also reduce the complexity of the part that is flying, right?
Exactly. It's a win-win.
Absolutely. And as we've mentioned many times, simple scales, right? Keeping going with the questions here. We do have a question about what propellants does this rocket use to feed those engines?
Yes, so both the first stage and the upper stage engines are powered by liquid oxygen and kerosene.
Gotcha. And when we're looking at a screen there, we're seeing some gaseous oxygen venting from those tanks, and the frosty part of the rocket is that super cold liquid oxygen tank above the ambient temperature kerosene tank. So that's what you're seeing on your screen. And again, we'll see that continue to get more solid frost on that upper part as the propellant loading operations catch up and we can get towards releasing this hold. And we talked a little bit about this yesterday, but that ice that's kind of forming the frost on the outside of the rocket, that's a negligible amount of mass that shouldn't affect the flight of the rocket.
Yes, that's right. And you'll potentially see large chunks of ice as it forms fall off the rocket that is expected.
Diving back into some more chat questions. F1 here, do you believe that reusable vehicles, full or partial, are necessary to achieve the goal of daily spaceflight, or is it possible to get there with expendable vehicles?
Well, as we've talked about, our strategy really focuses on expendable vehicles. We are not pursuing reusability at this time. We believe that we can make a rocket that is much cheaper and more efficient if we focus on expendable vehicles.
Gotcha. Another question here. There is a lot of talk about space's commercial future, and what is Astra's role in this new era of commercial spaceflight?
Yeah, certainly. So Astra's mission is to improve life on Earth from space, and we do that by providing services to satellites that are helping to observe and connect and improve the health of our planet. And so what we hope to offer in the future of commercial spaceflight is unprecedented access through daily space delivery at affordable prices by using our launch system that is manufactured at scale.
We also have a question here asking, and I think I might be able to even field this one, how many cameras do we have tracking the rocket? Are they all automated, or do you have any camera operators? I can give a quick shout out to Mr. Brady Keniston, one of the NASA spaceflight photographers out there with Astra today. Actually, you're looking at his camera view. The rocket will pop out from those trees after liftoff. So we've got a human camera operator out there, as well as a lot of those robotic cameras. And I believe there's one other tracking camera that's actually pretty cool to talk about.
Yes, we do have a tracking camera on our dish antenna as well. So that is the system that we use to provide radio link, and so we have that camera ready to go. So we have lots of camera feeds that we hope to be able to show you during flight.
And if I understand that correctly, that camera view is literally on the telemetry tracking dish, which of course has to be pointed at the rocket. So by product, you have a camera pointed at the rocket.
It is simple scales.
Yeah,
like
there you go. We're also seeing some really cool onboard views. There's an onboard camera on the rocket's first stage. You can see the frost forming on the outside. We talked a little bit about this yesterday. Don't know how reliable that camera feed will be once the rocket actually lifts off, but assuming it does work, we're going to show those as much as possible because they are really cool views. And back to our kind of ground-based camera views again. This countdown currently in a hold, so we're taking some questions in the meantime while those propellant loading operations catch up so they can resume the countdown. Our next question from chat asking about the Kodiak, Alaska launch site. Looks pretty beautiful out there now, but a question in chat asking, is this launch site still usable in the middle of winter?
Yes, absolutely. Our last launch out of Kodiak was actually in December in the middle of winter. So it is a different picture, a lot snowier, but no less beautiful. Our red team tends to be bundled up in beanies and big coats, but we do use this launch site and have operated at this launch site year-round.
And you mentioned the red team. We have a question in chat about talking about the red team leader. Who's the red team leader today? And just tell us a little bit more about the red team out there in Kodiak.
Yeah, so our red team leader is Adam Frisch, who I'm sure is very excited to get this shout out right now. So kudos to whoever friend posted that question. And our red team is a team of 6 folks who go up to Alaska with all of our launch support equipment and our vehicle, and they are the ones who set everything up and ensure the safe operation of everything on the ground. So it's pretty remarkable that it only takes 6 people to set up the entire launch site that you see in front of you today.
And the other half of the launch operations team in Mission Control, can you tell us a little bit about where that Mission Control is situated?
Yeah, so our Mission Control, we spent a few minutes ago, spent some time walking through those different roles, but that Mission Control team is right here at our headquarters in Alameda. They're sitting directly behind our broadcast area. If you've seen that, this is in our factory, and in addition to these 8 folks, we have about a dozen engineers who are the responsible engineers for the different systems on the rocket. They're the folks who will be polled during our go, no-go polls throughout our countdown, and they are actually also dispersed throughout our factory office. We have a great setup where they're able to be at their desks with a light to notify folks that they should not be disturbed and are in operations. So we are a very lean team as we control the vehicle and operate it for launch.
I have another question in chat here asking, are there any superstitious rituals done before each of Astra's flight?
Well, I don't know if there's any official rituals, but we certainly have our own little superstitions here. Our launch conductor, Chris Hoffman's mohawk, tends to change color as we enter a launch campaign.
Okay.
There's quite a few folks in here who are wearing their lucky socks. I myself listen to some pump-up music on my drive-in, in particular No Scrubs by TLC. It's for good luck today.
Excellent.
So we do have our share of fun traditions that we try and keep our fingers crossed for a smooth ride to orbit this afternoon.
Absolutely. I can definitely understand that no scrubs philosophy, hoping for a successful countdown today. Continuing on with some questions here. One question about what this rocket's name is. We're calling it LV0006. We're also calling it Rocket 3.3. You want to explain about that a little bit?
Sure. So Rocket 3.3 is the version number of this rocket, and LV0006 or LV0006 is the serial number of this particular rocket. So that Rocket 3.3 number refers to the precise configuration of this rocket, and that includes the changes that we made from our previous flight in December, which was for Rocket 3.2. But LV0006, LV6 is the name of this vehicle, and we're focused on that serial number because we hope to make many copies of this same vehicle, and we also hope to continue to increment those numbers and someday be at LV9999 and beyond.
Excellent. Continuing on with the questions, another question about the engines that we're using. We know there's the one type of engine on the first stage, there's 5 of them, and then a different engine on the upper stage. Want to talk about those a little bit more?
Absolutely. Always happy to talk about our engines and our fantastic propulsion team that develops them. We've talked quite a bit about the first stage Delphin engines, but the upper stage engine is Ether. It is a pressure-fed engine, and we have one of those powering the upper stage of LV6. It has 740 pounds of thrust at vacuum, and it is also powered by liquid oxygen and kerosene. And again, just like the first stage engines, our upper stage Ether engine is also developed, built, tested, manufactured entirely in-house by our team here in Alameda.
Gotcha. Another question about what we're looking at on screen here, actually. Is there a flame diverter as part of that launcher underneath the rocket?
Yeah, it's a little difficult to see, but in that sort of cube-shaped structure that the launch stool that the rocket sits on, there is something that kind of looks like a slide. That is the flame diverter for the rocket.
Yeah, we can make it out just in this camera view. You can kind of see it on the bottom there. It'll be nice and obvious at engine ignition. You can see the thrust getting diverted out to the side. So once we reach that milestone, it'll be even more visible. But yeah, you can just make it out in this camera view a little bit.
And we also do have a water deluge system. The deluge test will happen at about T-minus 20 minutes or so as one of the final steps before we enter our terminal count. And that water deluge system serves the purpose of suppressing sound and as well as getting rid of any flames that may fall astray to protect the beautiful landscape and preserve the safety of people and property at our launch site.
Right now, we're continuing on with some questions from chat. In the meantime, if you're just joining us, we are at T-minus 30 minutes and holding. Team's just working to catch up on some propellant loading operations prior to releasing the hold. So we're standing by for a new launch time once that hold can be released. Taking another question from chat. Carolina, someone's asking, what is the next Astra mission?
Well, we are hoping to and on plan to complete 3 missions this year, so you'll have to stay posted on our news for updates about our next mission, but we plan to complete 3 flights this year.
Gotcha, and that'll be more of a monthly launch cadence, which is a part of that ramp up towards the eventual goal of daily on launch operations.
That is our hope.
And we have a question about that. Someone asking about what are Astra's kind of thoughts or opinions about the environmental impact of launching these non-reusable rockets, these expendable rockets, at a daily launch cadence?
Absolutely. So we do have most of our rocket is made out of aluminum, which does corrode in salt. So it does degrade. The first stage does degrade when it falls into the ocean. Also, as a smaller vehicle, we are much lighter and can use a lot less fuel. And as we are able to calculate and project where the first stage will land during and after its flight, this not only serves the purpose of helping us to ensure safety, but we are also looking at long-term options to minimize the ocean debris. And similarly, in when it comes to space debris, the materials that we use and the satellites we launch are not intended to remain in orbit forever. And so when the upper stage and theoretically any payloads we launch do fall out of orbit, they will burn on re-entry.
Gotcha. Continuing on with more questions here. We do have one asking about these hoodies. I'm wearing one right now. I don't know if we can cut to it really quick. I can show off the Astra on the shoulder. If there we go, you see. So we do have a question in chat asking, how can we get these hoodies?
Well, we don't have an Astra merch shop at the moment, so the only way to get one of those hoodies is to be an Astra employee or be one of our close friends. So you can learn more about joining the Astra team at astra.com/careers. We have many roles open and are hiring very quickly as we scale up our team and continue to work towards our goals. So if you are interested in working with us and getting cool hoodies, we've got cool water bottles too. So please check out astra.com/careers to learn more about how you can join our team.
And we also have an update to share. We are currently in a T-minus 30-minute hold while they are working on catching up on propellant loading operations. We are hearing that we are getting close to releasing that hold, so we will stand by for a new T0 and provide that as soon as we have it. But stand by for a release of the hold before too long. To kind of finish off that thought about joining the Astra team, we each have one specific question. Does Astra anticipate hiring any DevOps engineers in the near future? Asking for myself, says Alexander.
Well, Alexander, we have so many open roles that I don't know to speak to specific ones, but you can check out our careers page and see the available job postings.
A relevant question asking how many people work at Astra currently?
We are growing so quickly, it is kind of hard for me to keep track, to be honest. But we are, as we've said before, we are still a pretty small and nimble team of a couple hundred folks. So we are growing rapidly, and that number is constantly changing.
And again, as we are getting close to the release of this hold, hopefully, let's go ahead and listen into the countdown net as controllers get ready to resume the count.
Astra LC on countdown will be picking up the count with 30 minutes remaining at the top of the hour.
And as we just heard, again, we're at T-minus 30 minutes and holding, and it sounds like they're going to aim to release this hold at the top of the hour, so 3 o'clock p.m. Pacific time, which translates to a new launch time of just about 3:30 p.m. Pacific time. Again, we're standing by for the hold to actually be released, but that is our new no earlier than launch time, 3:30 p.m. Pacific time. And so we will stand by for the countdown to resume in just under 2 minutes.
This is LC on countdown picking back up. We are currently at step 102. FTS, can you verify that mission data load values are ready to be loaded onto the AFTU?
FTS confirms the mission data loads. They're ready.
Please run CAS software as required.
CAS is running on both AFTUs.
Safety, confirm that you have a head count on all Astra employees and guests in Kodiak.
Safety can confirm, roll call on all guests. I have 2 at AMC, the rest are with me.
Copy, thank you.
And as you've just seen, we have released the hold. We're at T-minus 29 minutes and counting now, heading towards a new T0 of 3:30 p.m. Pacific time for the launch of Astra's LV0006. Carolina, can you give us an update on how the countdown's proceeding?
Everything is proceeding nominally. So we have released that hold, and we have made all of our operational corrections to address the issue with yesterday's abort. So everything will hopefully proceed smoothly from here.
As we get closer to the business end of the countdown, we're going to want to turn our attention to the countdown net and the launch proceedings. So we're going to get through a couple more questions here before we get to that point. A question asking about the process for getting the shipping containers out to the pad look like. Is it trucks, planes, boats? What's used to get all that material out to Kodiak?
So we will generally ship everything in standard shipping containers that will be trucked and shipped by boat, but we have also shipped our rocket by air cargo in the past and do have that capability as well.
And on a related note, Astra is known for this mobile launch system. It's a very defining part of the Rocket 3 architecture. What existing infrastructure is needed at Kodiak to host all of those systems?
Yeah, so we like to say that all we need is a concrete pad and an internet connection, and that's pretty true. We have the capability to bring pretty much everything else we need to the launch site in order to set up and fly.
Gotcha. And another question about that launch system, asking how does the rocket firing on the stand affect that launcher system, and is there any refurbishment needed between engine firings?
So as we've mentioned before, that everything that you see, we pack up and use to test at our headquarters in Alameda, at other test sites near our headquarters, as well as shipping that up to Kodiak. So we do have a pretty well-established procedure for checking out our systems and making sure that any repairs can be made. But generally, these systems are pretty rugged, and we pack them up and send them on to their next destination. So after the ignition yesterday, our systems continue to be in good shape.
Another question about the launch site, asking what are the two, in parentheses, towers for?
Yeah, so this black tower that you see on the left side of the screen now, and now you see both of them on either side. That's our lightning protection system that prevents the rocket and the launch system from being struck by lightning.
It would not be a NASA spaceflight stream without talking about lightning protection system. We have to hit it every time. It's basically in our contracts. Continuing on with the questions here, is this a cargo-only rocket, or could Astra one day carry a human capsule?
We are focused on sending cargo missions. That is part of how we're able to focus on low-cost vehicles and manufacturing techniques, because we don't need to provide all of the life support systems you need to send people. We're pretty fragile cargo, so we're sticking with satellite payloads.
Gotcha. Again, if you have questions, throw them in the chat. Tag us at NASASpaceflight. We're coming up on T-minus 25 minutes and counting, and that terminal count starts at 15 minutes. So we've got just under 10 minutes left until we get into the really business end of this countdown, and we're going to want to keep our focus there once we reach there. Right now, you can see the rocket is propellant loaded. You've got the liquid oxygen tank, nice and frosty, in the middle of the rocket. Below that is that bare aluminum for the kerosene tank at ambient temperature. Above that, you can see the inner stage and the payload fairing. Those two together are encompassing the upper stage. And the mass simulator payload, the test payload from the United States Space Force's Space Test Program, which of course will not be deployed from today's launch. But that is the vehicle you're seeing next to the strong back with all of the umbilicals. You can see some venting from the liquid oxygen and the gaseous oxygen venting out of those systems at this beautiful launch site in Kodiak, as we are counting down towards the launch of LV0006. Yesterday we had an abort at T0, and we have a question in chat asking about what happens to that propellant after you have to scrub a launch.
Yes, so yesterday after we scrubbed our launch attempt, we essentially pump the propellants back off the rocket and start fresh today. So the same system that we use to load propellants onto the vehicle is also set up to be able to pump them off in a safe way and not dump them overboard or anything like that.
So everything that we're not seeing, vented from the vehicle, obviously there's some oxygen venting because that's how you keep tanks pressurized at the right levels and things like that, but all of those other commodities just come right back off the rocket and are used again.
Mm-hmm, that's right.
Gotcha.
Loading. Loaded.
Igniter is unchanged. 106, Victor 9.
106, Victor 9. Loading. Loaded.
Thank you, Delphin. Ether, can you please provide your config?
Ether is 101, Victor 12.
Ether controller 101, Victor 12. Loading. Loaded.
Elder's good.
Guidance, what is our latest guidance config for the vehicle?
We're going to use guidance version 5 Victor 131 L4 balloon.
Copy that. Guidance version 5, Victor 131. Loading. Loaded.
Copy, thank you all. The config is late loaded. Tango in VB1 turn on off PDBs. Please give me a GNC setup. Call out when complete.
Copy that. Setting up.
And what we just heard, they have loaded those software engine configurations into the rocket as we get towards 21 minutes and counting now. And that was the Tango call sign, which we have a question in chat about. We heard some callouts during the countdown yesterday. Tango is always ready. Is Tango still ready?
It appears that Tango is still ready. And that Tango is our vehicle controller, Steve Lai, and he is loading that software configuration onto the vehicle. We're getting weather data through weather balloons during our countdown procedure, so we always like to have the latest and greatest before we attempt to launch.
I don't want to spoil any future NSF developments, but I must say we have some cool audio bits in that opening sequence, and I think we might have found a new one here at Astro because that's just so cool. Another question from chat here asking about those Apollo engine thrusters, the Apollo Fusion thrusters. Can you talk a little bit about that?
Yeah, so the Apollo Fusion is a company that Astra recently confirmed the acquisition of back in July, and we are very excited to have that technology and team on board. They share a lot of, their approach is very similar to a lot of our philosophy at Astra about rapid design cycles, focusing on ease of manufacturing and assembly. And this past week, Apollo Fusion Thruster did ignite in orbit, which is an amazing accomplishment for that team. And together we're working on providing rapid and low-cost access to space.
Gotcha. We're coming up on T-minus 20 minutes and counting, just 5 minutes away from the beginning of the terminal count, so a brief status update if you are just joining us. We are targeting a liftoff time of 3:30 p.m. Pacific time after a hold for some propellant load operations to continue. All systems appear to be operating nominally right now. Carolina, can you just give us a status update of where we're standing now?
Yes, we're just inside T-minus 20 minutes, and as you heard a few moments ago, we have loaded our final software configuration. The team will now be working on spinning up our first stage engine pumps, and we'll be getting into our final preparations, including our water system, our water deluge system test, and that will signal that we have entered the terminal count at T-minus 15 minutes.
And if you're tuning in after yesterday's attempt, we know we did have an abort at just about T0 yesterday due to a engine configuration, and they have applied that corrective issue to come back towards today's launch attempt. We also had a hold during the webcast today of the propellant loading operations just catching up before we released and targeted this new 3:30 p.m. Pacific time launch, and everything proceeding nominally now. This is the test flight for the U.S. Space Force's Space Test Program, a test payload on board today that will not be deployed, but Astra's third orbital launch attempt with LV0006, the debut of the rocket version 3.3. As we come up on 18.5 minutes, we're going to go ahead and listen in as the teams prepare to enter the terminal count at T-minus 15 minutes.
Delphin, please confirm status of ESC flags.
ESC flags are nominal.
Tango, toggle dry spin both.
Dry spinning both.
Back to idle. Delphin, please confirm results of pump spins.
Pump spins are nominal.
Copy, thank you. Tango, deactivate AV1 power ESCA dry spin.
Machine deactivated.
Delphin, confirm your system is ready for launch.
Delphin is go for launch.
Ether, confirm your system is ready for launch.
Ready for launch.
CDH, please set aux ISO target pressure back to 90 psi.
Set.
Tango, verify vehicle looks ready for launch aside from tank levels and pressures.
In work.
GNC, confirm wind profiles still look acceptable for launch.
Confirmed, wind profiles look acceptable.
Tango on countdown, vehicle looks good.
Copy. Tango on the buttons interface, please toggle spark for 30 seconds.
Copy that. Sparking in 3, 2, 1. Spark. Spark off.
Delphin, please confirm current on all 5 igniters.
Current draw is nominal.
Copy, thank you. This takes us into our water test. Tango, in the water system machine, toggle deluge to on. You will toggle back off on my call.
Copy that. Deluge on now.
Off.
Off.
Good. Deluge test. Tango, in the water system machine, toggle pump full to false.
False.
Team.
And you just saw the successful water deluge test as we have entered the terminal count at T-minus 15 minutes and counting. Carolina, let's go over those details for today's mission now that we've entered terminal count.
Sure, Thomas. LV-6 is Astra's third orbital launch attempt and a demonstration mission for the United States Space Force Space Test Program. It's also our first commercial orbital launch, meaning the launch is being conducted under an FAA commercial launch license. Our goal today is to successfully reach orbit with a test payload that will not be released. This orbital demonstration launch allows our team to verify numerous upgrades to our launch system since Rocket 3.2 in December of 2020. Today's launch is an important milestone in our work at Astra and a crucial step towards launching our next payload. You can find more information about the flight at our website, astra.com, and we explain more about our approach to reaching orbit and our other objectives for today's mission. Before we get further into the count, I'd like to give a big thank you to the entire Astra team and their families watching with us today. We really couldn't do this without you and all of your support, so thank you again. As a reminder, back in December, Rocket 3.2 successfully passed the Kármán line, the 100-kilometer altitude that's commonly used as the demarcation of space. We learned that Rocket 3.2 shut down about 12 to 15 seconds too soon after depleting its fuel, only half a kilometer per second short of orbital velocity, which sounds like a lot, but that is so close. And since then, we fine-tuned the mixture ratio between our kerosene fuel and our liquid oxygen to propel us the rest of the way to orbit.
As we get closer to liftoff, let's talk a little bit about the vehicle that you're going to hopefully see liftoff in just under 13 minutes. LV0006 is a 2-stage launch vehicle, each stage running on liquid oxygen and liquid kerosene. The first stage is powered by 5 electric pump-fed Delphin engines. They each produce 6,500 pounds of thrust, and those are made in-house by Astra. The upper stage, also built in-house by Astra, powered by a single pressure-fed engine called Aether.
Looks
software configuration changes that were made, and we expect to be picking up the count shortly. So we'll listen in on the countdown to hear that update.
This is Astra LC on countdown. We have resumed count. We held briefly to make a minor change to an engine configuration. Picking back up in terminal count at step 137. FTS confirm. Astra FTS is still enabled and nominal.
FTS confirms.
And as you can see, the hold has been released. We're back at 13 and a half minutes and counting. Just a little brief hold, but back into the countdown. We are in terminal count for Astra's launch of LV0006. That gives us a new T0 of 3:35 p.m. Pacific time.
And prior to the hold, we were talking about some of the changes to this vehicle. So to increase our payload capacity, this vehicle has several upgrades from Rocket 3.2, which we launched in December. In LV6, we've stretched the first stage tank to increase propellant capacity, reduced the mass of the upper stage, added additional sensors to gather more data about flight environments, and consolidated over a dozen individual components on the upper stage into one single assembly. The main propellant load has been completed, and we're continuing to top off oxygen prior to launch. And so, as we've mentioned before, the vehicle is now in terminal count, so we're performing the final checks before we give a go for launch. We've talked a little bit throughout this countdown about the red team, but I also want to take another moment here, if you're just joining us, to recognize them. The rocket is controlled from our headquarters here in Alameda, but we do send a red team of 6 Astra personnel to the Kodiak for that launch. And because our rocket and support systems were designed with simplicity in mind, we only need a very small team on site for the launch. It also helps us limit travel, which has been a key consideration during the ongoing COVID-19 pandemic. All 6 members of the red team are taking regular COVID-19 tests to protect the health and safety of everyone involved in this mission. We are at just under 12 minutes to liftoff, and we'll continue to listen to the countdown net. In a few moments, we expect the launch team to conduct a go, no-go poll to proceed into tank pressurization and launch.
Deactivate Ox1 OV201 first fill.
Off.
Ox1 OV102 return.
Off.
Ox1 OV100B101B fill.
Off.
Toggle off and deactivate fuel for operate.
Off.
Fuel 3 supply.
Off.
Fuel 1 FE 300 upper fill.
Off.
Fuel 1 FE 200 first.
Off.
AV1 radios.
Off.
AV1 rocket support cart.
Off.
Please confirm the following are still enabled and running. 0 stop purging.
Active.
AV1 manage polling.
Active.
AV1 manage power systems.
Active.
All flight helium machines.
Active.
VB1 first stage power.
Active.
VB1 upper stage power.
Active.
VB1 turn on off PDBs.
Active.
Water system.
Active.
Tango, at this time, I would like you to enable the launch machine.
Active.
Toggle locks topping.
Toggled.
On countdown, team, this takes us to step 144. This is the poll for tank pressurization and launch today. After this point, any system issue must be called as a 3-word hold. If there are no concerns for flight, call go. Otherwise, call no go. Red lead.
Red lead is go.
FTS.
FTS is go.
Delphin.
Delphin is go.
Ether.
Ether is go.
Odin.
Odin is go.
Inco.
Inco is go.
Ace.
Ace is go.
Launcher.
Launcher is go.
Orbit.
Orbit is go.
Booster.
Booster is go.
GNC.
GNC is go.
FAO.
FAO is go.
CDH.
Go.
Tango.
Go.
Safety.
Safety is go.
LD.
LD is go.
LC is go as well. Tango and AV1 manage polling. Set us into ground only mode, please.
Ground only.
And as you have just heard, the poll has been conducted and the Astra team is go for launch.
If you are just joining us, we are currently just under 9 minutes away from liftoff for Launch Vehicle 6, or LV0006. This rocket is an orbital class vehicle, so if everything goes well, it is fully capable of making it to orbit. However, as a reminder, today's mission is still a test flight for Astra.
Yes, historically, achieving orbit is very difficult, and for this reasons, we are very realistic about our expectations. Today is our 3rd attempt to reach orbit and our first test with a sample payload provided by the Space Force to simulate mass, and again, we will not be deploying this test payload. For the next several minutes, the team is loading the final flight software onto the vehicle and going through our final checklist for launch.
Right now, we're at just about T-minus 8 minutes and counting. As we enter these final minutes of the countdown, we're going to turn our attention to the countdown nets, to the rocket on your screen, and I'm going to hand off commentary to Carolina for Astra's 3rd orbital launch attempt. Carolina, it's all yours.
Thanks, Thomas. The major flight milestones that we will encounter during flight are displayed on the left for you to follow along. At T-minus 3 seconds, the 5 first-stage Delphin engines will ignite. And if the engine data looks good, the hold-down mechanisms will release at T0 and the rocket will begin its trip to space. At T plus 12 seconds, the rocket will begin pitching downrange to fly south over the Pacific Ocean. LV6 will reach max Q, which is the period of maximum aerodynamic pressure on the vehicle, at T plus 1 minute and 15 seconds. Main engine cutoff, or MECO, is the end of the first stage burn, and that will occur at T plus 2 minutes and 50 seconds. This is followed by fairing separation and stage separation, and at this point the rocket will be in space. After stage separation, upper stage ignition occurs at T plus 3 minutes and 5 seconds, the beginning of an approximately 5-minute long burn until SECO, or second engine cutoff, at T plus 8 minutes and 20 seconds. And since we're not releasing our payload today, the vehicle's systems will simulate a signal for payload deployment at T plus 8 minutes and 30 seconds. If we make it to orbit, we would consider this flight to be extremely successful. We are just about 6 minutes and 30 seconds to launch, and all of the systems are looking good. So we are waiting now for the range to give us the go-ahead for launch, and we'll continue to listen in to the countdown net.
RCO, LC on countdown. RCO LC on countdown.
This is RCO. Range is
RCO.
green. You are authorized to launch.
Copy. Thank you, sir.
And we're at 5 minutes to T0, and as you've just heard, the range has given us the go-ahead. We are green. And I believe we've got a bit of a crowd gathering here at our headquarters, watching on our big screen here in Alameda. We also have many members of the team watching from home. And at T-minus 60 seconds, the vehicle will transition to its internal control. So we're at 4 minutes and 30 seconds from liftoff. And we will continue to listen to the countdown for these final minutes before liftoff.
RCO LC on countdown. At this time, please verify the range is recording all telemetry.
This is RCO. Range is recording.
Thank you. Control room, if you require RF data after launch, be prepared to switch over your Grafana pages. FSO, be prepared to issue option command at T+164, calling out at event.
FSO copies.
3 minutes. Reminder, control room, any 3-word hold from here on out is an immediate abort, regardless of source. FTS at this time, please send Master Enable and Watchdog on AFTU.
In work.
Two minutes.
Master Enable and Watchdog have been issued on both AFTUs. Both AFTUs ready to fly.
Copy, thank you.
Under 2 minutes to go till Astra's launch of LV0006.
$90 seconds. Ace, at this time, start PSD recordings.
Both started.
$60 seconds. Vehicle is on internal control. First stage LOX tank is pressing. First stage fuel tank is pressing. Upper stage tanks have gone to liftoff pressures. "30 seconds. "15. 10 seconds, water system on. 8, 7, 6, 5, 4, 3, 2, 1, ignition, 0.
First motion.
First motion.
Our next objective is Max Q. Looks like we're getting some really great footage from our onboard cameras.
Rocket has cleared the island. Approaching nominal downrange trajectory, tracking.
And at this point, we should have also passed max Q, which is the period of maximum aerodynamic pressure on the vehicle. This is a significant milestone and the most physical stress the vehicle will experience during launch. Our next milestone is MECO, or main engine cutoff, which is about 30 seconds away.
Vehicle is passing through max Q.
Terminate sense.
Terminate received.
And as you might have seen, there appears to have been an anomaly with the vehicle in flight. And we will first and foremost ensure that our team and others are safe. We take great safety precautions to ensure that no one was put in danger by an event like this. It does look like we got about 2.5 minutes of flight data, which will be incredibly helpful as we make improvements to our next vehicle on our way to reaching orbit. And any flight where we get some data that we can learn from is a successful one in our mind. Although we did not achieve our primary objective today, our team will work hard to determine what happened here. And as we dig into the flight data, we are optimistic about the future and our next attempt.
Let's go ahead to some quick words from Astra's founder and CEO, Chris Kemp.
Today, after a successful launch and liftoff, Astra's launch vehicle experienced an anomaly in flight. While we regret that we were unable to accomplish all mission objectives for the Space Force, Our team captured a tremendous amount of data from the flight. We will work closely with the FAA to complete a mishap investigation. Behind me is LV0007, which will be updated based on what we learned from the flight so we can begin servicing our backlog of over 50 contracted launches. I want to thank our team here at Astra, our partners at the Pacific Spaceport Complex, and I also want to thank our government customers and partners, the Department of Defense, the United States Space Force, the Defense Innovation Unit, FAA, FCC, the Coast Guard, and the community of Kodiak, Alaska. We look forward to seeing you at our next launch.
For now, that is going to conclude our live coverage of the LV0006 mission. I want to give a big thank you to Astra for allowing us to be very transparent about today's test flight, and just a big thank you for today's partnership and bringing live coverage of the mission. A big thank you to you, Carolina, for joining me as well.
Thanks, Thomas. It's not what we were hoping for today, but thanks for having us, and we hope to be back on the pad again soon.
Absolutely. From all of us at NASASpaceflight, the well wishes to the Astro team, hoping to see them back on the pad soon. For all of you watching, thank you so much for joining us. Stay tuned for more spaceflight news coverage. Until next time, see you then.
Propulsion continues to be normal.
The chamber pressure looks good.
Traveling up. Roger, roll, Atlantic.
Water towers, fly!
Echo Delta nominal.
Flighting outside SC off. Bring in SC off.
Yikes. You bet. Concur. We don't need any more of these.